previously we ended with this result, and now what you're going to do is evaluate further and try to reach a good conclusion. Alright, so what can we do with this? We'll try to manipulate this algebraic expression, into something that we can work with easily. Alright, let's try it out. So this is what I'll do. I'll do n factorial and do n minus k factorial. Alright. And try also to separate 1 minus k factorial from it. And also go and distribute this exponent k into the argument. Let's try it out. Lambda k all over nk. Alright, and finally I can then work on this and show that it can be written as 1 minus lambda n raised to n times 1 minus lambda n raised to minus k. Alright. Now, one of the hardest thing about this manipulation is for us to understand what this means. Or maybe we can try and simplify it. Now the best way to work on it is to imagine that n factorial can be written as n times n minus 1 times n minus 2 plus, not plus, but times dot times n minus k1 times n minus k times n minus k minus 1 and blah blah blah. Alright, and the one underneath obviously is going to be n minus k times quantity n minus k minus 1 blah 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 blah. Alright, from this you understand that this n minus k cancels out, the n minus k minus 1 cancels out there, and all other terms in here cancels out. So what is left for us is this term. There you go. So let's go and slide down a bit. What it means now is we can further simplify our expression, the one above, which is right here. We can further simplify this and combine it with this and get an expression which is equivalent to n times n minus 1 times n minus 2 times n minus k plus 1 all over nk, and all of this multiplied to lambda k all over k factorial, and the other guys which is left behind 1 minus lambda over n raised to n and 1 minus lambda over n raised to minus k. Alright, perhaps we can still do something about this. And you notice that this expression on the numerator, which is n times n minus 1 times n minus 2, etc., which is right here. There's a lot of other terms in there, times n minus k quantity plus 1, is a polynomial. And the number of terms of this polynomial is equal to k terms. So it means that the total number of factors in here is k factors. It means that whenever we try and do this, there is k number of factors on this numerator. K factors. Alright, which means that the numerator itself is just equivalent to n raised to k, because there's k factors, plus a n k minus 1 plus b n k minus 2 plus blah 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 all over nk. So that is a much simplified expression, and all the other guys just copied in there. Right. I guess this is a good stopping point. And sorry. Don't forget about the limit as n approaches infinity. So we will end here and continue the video on part 3. Thanks for watching.